Okay, this is the last session of acids, bases and salts. Also you have, this is for coming Sunday exam also, and after completing this we will start physical change and chemical change. In the previous we are discuss about indicators. What are the indicators? Indicator is nothing but it indicates the color of the substance, whether it is acidic or basic or neutral. That is the indicator. And yes, this is the indicator. Those substances which are used to test whether substance is acidic or basic in nature, that is the indicator. And you know, indicators are two types, that is the natural indicator and synthetic indicators. Natural indicators, for examples, turmeric. This is used in our daily life in kitchen hall. The turmeric we have make a turmeric stain, that is 1 or 2 drops of acid are added, that color is not changed, remains same turmeric stain, and we are added 2 or 3 drops of basic solution for turmeric paper, that is gives the red color. Again the red color, that is the brownish red, the red color again yellow color with acid solution. That is the, no doubt at all, turmeric is a indicator. That is the natural indicator. It is one of the important indicator. Acidic solution or basic solution is decided by the turmeric paper. So that is the natural indicator. One more natural indicator is China rose. It is also called hibiscus. China rose petals taken in or soaking in hot water, it become a pale pink color. The pink color solution is added to acid or base. Added to acid gives the red color, that is the brownish red, and that is indicates the acid. The same pale pink solution of China rose red, that gives added basic solution, it gives the light greenish solution, that is indicates basic solution. So no doubt at all, China rose also one of the best natural indicator. Again one more natural indicator, everybody feel, that is the litmus paper, that is the paper. Everybody thinking like that. That is a misconcept. The litmus paper also natural indicator. It can be obtained from lichens. So it is these lichens prepared from blue peppers or red peppers. From these lichens we are prepared litmus paper, that is the blue litmus paper and red litmus paper. These are also indicates the, tell me Nana.
Lichens means what, sir?
Lichens is the mixture of, that is the biological term, that is mixture of fungus in the petal, China rose petals, that is the mixture of the fungus and organisms. Okay, they are obtained from the natural.
Okay, sir.
Okay. Again, so that's why litmus paper is not a, don't feel like that is the paper. That paper can be obtained from the lichens. That is the biology word lichen. It is a mixture of the fungus. They are obtained from the fungus. So that is called a litmus paper. Is also called litmus paper, may be red litmus or blue litmus. that is also called a natural indicator. Blue litmus turns red in the presence of acid. In the presence of base, blue litmus not changed. Red litmus, listening clearly, red litmus dipped in the basic solution turns blue. In the acidic solution, red litmus remains same, no change in the color. So these are the indicators. This is our last concept. And one more, another type of indicators are methyl orange and phenolphthalein. They are synthetic indicators. They are prepared in the laboratory, so they are called a synthetic indicators. Methyl orange, the color is orange color, light orange. That a solution added to methyl indicator, 2-3 drops of methyl indicator added to the acid gives the red color. Base, methyl orange indicator added to the basic solution gives the yellow color. So that's why it indicates the color of the substance, whether acidic or basic. So it is a methyl orange is an indicator. It is a good indicator, one of the indicators in the most preferably used in acid base titrations. Okay, next in this concept, competitive phenolphthalein or methyl orange, what type of color will be produced in the presence of acid or base? You should keep in mind. Methyl orange indicator in the presence of acid gives red or pink. Some books are red, some books are pink. Orange becomes pink, that is the red. Again, base, it is react with base to form, added to the base to form yellow color, pale yellow or golden yellow. Again, final one, that is the phenolphthalein indicator. Phenolphthalein indicator. Phenolphthalein indicator is a colorless. It is added to the acid, become a colorless. Added to the base, phenolphthalein indicator is added to base, gives pink, pale pink color. That is called, you are continuously added, that become a red. The first of all, that is the pale pink, that indicates the reaction takes place. So that is the use of indicators. It indicates the color of the substance, whether it is acidic or basic. That is the indicator. Okay, these are over. Next, one more important concept, pH scale. You are watching the next slide about pH scale. And what is the pH in our daily life? Importance of pH in our daily life. You know very well about acids. Acids are found in tartaric acid, found in tamarind, grapes, and apple, that is the malic acid, vinegar, that is the acetic acid, radans or stings of base, that is the formic acid, that is also called methanoic acid, and many more acids. These are harmful acids and useful acids. All organic acids are non-corrosive acids, that is useful in our body. In our stomach also one acid is there. Which acid? That is our stomach containing what type of acid? In our stomach one acid is there. Anybody? Reply. In our stomach.
Sir, in our stomach there is an acid which would be melting the food particles.
The acid name is in our stomach containing hydrochloric acid. But it is not damaged in our stomach because mucus is there. Mucus is used as a protective wall, protective wall. So it is protect from acids, but HCl is a strong acid, that is the inorganic acid, but not a damaged in our stomach, not damaged, because of mucus is protect mucus is nothing but it is a protective wall in our stomach. Again, these acids, how can decide acid or base? Decided by the indicator with color. But also one more experiment, one more concept is pH scale. pH scale was proposed by Sorensen. It indicates the 0 to 14 values. pH generally the negative logarithm of concentration of H plus ions. Till now in our laboratory it is used. Is it acid or base is decided by pH value. What is the pH? pH is nothing but power of, P stands for power, H stands for H plus ions. The power of H plus ions, that is the pH. You can see this slide. Here 0 to 14, 0 to 14. Here 7 is there. These are the neutral substances. Substances having pH value 7, that is the neutral substances. Pure water is neutral. pH value less than 7, from 0 to 6 something, that values are called acids. pH value more than 7 to 14, more than 7 and 14, in between 7 to 14, that values are called alkaline, that is the basis. It is very important. How can decide is it acid or base? Based on the pH scale. pH scale is measure the pH value of the substances. pH is nothing but the negative logarithm of H plus ions, that is pH equals to negative logarithm of H plus concentration, that is the pH. That is the negative logarithm of H plus concentration, that is the pH. Simply, that is the power of hydrogen. Already you know which substance gives H plus ions, that is the acid. Which substance gives OH minus ions, hydroxyl ions, that is base. Their pH value 0 to 6 and in between 6.6, 6.7, 6.8, also less than 7, so that is also acid. Those substances have lower pH value, that will be negative, that will be more acid, that will be strong acid. Which substance have more pH value, that is the weak acids. Which substance have less pH value, that is the strong acid. 0.5 something, 0.1 something, 0.2 something or 1.5 something, that is the strong acids. Hydrochloric acid, again negative, -1, -2, -3, 0 and something. And pH value 11, 12, that indicates the less acid. That means more basic. Once again, which substance have less pH value? Because of pH equals to negative logarithm H plus ion, that is also written as minus log, that is log 1 by H plus, So pH is inversely proportional to concentration of H plus ions. More H plus ions, less pH value. Less H plus ions, more pH value. H plus, concentration of H plus indicates acid. So more H plus ions, this is inversely proportional to pH. More H plus ions, that is the less pH. More pH, that is the less H plus ions. That is weak acid. More H plus ion, that is a strong acid. Okay? According to explain this formula. It is introduced by pH scale is introduced by Sorensen. According to pH scale, in between 0 to 11, less than 11, more than 0, that values are acids. 7 to 14 pH value, the substances which have 7 to 14 pH values, the substances are called bases. Exactly 7.1, that indicates the more than 7. Exactly 7 pH value, which substance has exactly 7, that is substance is neutral. Pure water is neutral. Again, pH value less than 7, that substances are called acids. This is about pH. We are used in our, what is the importance of pH value in our daily life? Okay, plants and animals, pH sensitives, they gives the colors. Human body works within the pH range of 7 to 7.8. 7 to 7.8, our saliva in our body. Saliva indicates the basic nature because the more than 7. So saliva is basic nature. Acid rains. So acid rains are harmful. How can form acid rains? Metal oxides like nitrogen oxides, sulfur oxides, or carbon dioxides. These are mixed with water to form acids. Carbon dioxide react with water to form carbonic acid, H2CO3. CO2 plus H2O gives H2CO3. Sulfur dioxide mixed with water, dissolved in water to form sulfurous acid, H2SO3. Sulfur trioxide, SO3 mixed with water to form sulfuric acid, SO3 plus H2O gives H2SO4. Again, nitrogen dioxide react with water or dissolved in water, mixed with water to form nitric acid. Of course, nitric oxide also, nitric acid. These are all releases from the industrials. Metal oxides combination with water to form acid rains. In our country, most of cases acid rains are falling in Gujarat and Delhi in most states because they are industrial areas. So many pollutants released from the industries, that is sulfur dioxide, oxides of sulfur, oxides of nitrogen, oxides of carbon, they form acids with water. Okay. Acid rains are harmful to environment and aquatic life because of their pH value. Acid rain's pH value is more than 5.6. pH value is less than 5.6. That pH value more than 5.6 or less than 5.6, that is the more dangerous. pH value less, that is indicates the strong acids. 5.6. If pH of the rainwater is less than 5.6, less than 5.6, that is the more dangerous to ecosystem in our aquatic life. Aquaculture. What are the aquaculture? Fishes are growing, prawns, and these are used for food. But so many living objects in ecosystem, in the dissolved water, the water become a acidic nature due to the fallen acid rains. Just you think, what about? So to avoid pollutants, release of the pollutants from the industries, or maintain the precautions to avoid these oxides of non-metal, oxides of non-metals. Okay. High alkaline ionized water. Plants and animals are pH sensitives. They are indicates. Can you see the slide? Acidic 3 to 4, 5, 6, 7 most tap water, that is the neutral. Here more than 8, that is the alkaline, that is the basic in nature. pH of the soil. Soil pH is considered as a master variable in a soil, as it controls many chemical process that takes place. Already we have thought in neutral reaction. Soil becoming acidic or basic nature, that is harmful to growing of plants, that is the fertility of soil. It is a acidic, remove from the basic substances are used. It is a basic, remove that basic nature, used acidic substances. If specifically affects plant nutrient availability by controlling the chemical forms of the nutrient. The optimum pH range of most of plants between 6 and 7.5. That is the plants. More than 7.5, that is the basic nature is increases. Again, less than 6, that is the acidic nature is increases. Acidic, basic, how can decide it? That is the pH values. Lower pH value, that is the more acidic. Higher pH value, that is the less acidic, that means more basic. Okay. Higher acidic is dangerous to environment, or less. More basic also dangerous, also harmful. Okay, students, you can understand. Next, pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. That generally bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth. And whenever you use it, maintain the 5.5, maintain the neutrality with breath. washing the teeth the brush, we use paste. The paste is basic nature. In our acidic nature of the particles and basic nature of the particles become a neutral. Okay, that is the pH changes is the cause of tooth decay. And before the meal, after the meal, change the pH values. Change the pH values. So it is better to 2 times teeth the brush is a good habit. The maintain pH range, that is the neutrality, neither acidic nor basic. Self-defense by animals and plants through chemical warfare. Whenever plants are move our skin for self-protection, they release some fluids of acids. That is the ants release acid, that is the formic acid. Dear students, concentrate this point. Red ants move our skin. We feel sharp pain, burning pain because of the red ants for the self security release some acids, fluids of acids. That's why that pH value should be less than 7. So bees of stings are red ants release acids. The acid is formic acid. The formic acid also called as methanoic acid. Whenever ants bite, we feel irritate or burning pain. Okay, students, that is pH concept. According to pH, their pH less than 7. That is the acids. Other examples: battery. You know very well about battery. Batteries used sulfuric acid. Lead storage batteries, car batteries, and something. Batteries have sulfuric acid. Lemon juice also acidic nature because of citric acid is present. Citric acid found in citrus fruits like lemon, orange. Vinegar, acetic acid found in vinegar, acetic acid, that is also called ethanoic acid. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the pH scale. This is a pH scale. That increasing acidic character, acidic character, H plus ions are given easily, of course. 0, 1, 2, 3, 4, 5, 6, 7. That is the low pH value, more acidic because of pH is negative logarithm of H plus concentration. pH is negative logarithm of H plus concentration. pH and H plus concentration inversely proportional. pH is more, H plus concentration is less. pH is less, more H plus concentration, which is give the substance which gives more H plus ions, that is the strong acid. So acidic character and basic character also explained with respect to their pH values. Indicator indicates the is it acid or base, but pH value based on their value, is it acid or base? How can decide? pH value less than 7, that is the acids. pH value in between 7 to 14, more than 7 and 14, that is the bases. So pH value less, that is the more acidic. pH value more, that is the less acidic, that is more basic. More basic. Less acidic, that is the more basic. Okay. Sulfuric acid, strong acid, that's so that is pH value become a 0 to 1. Lemon juice and a vinegar and a 4 to 5, 4, 5, 6 normal range. That is the normal range. That is more. And that is used in the pH value. Acid range. Normal range of stream water. Milk. Milk have sour milk. In sour milk found lactic acid. So that is the acidic nature, because that is the less than 7 in between, that is the milk. Sour milk, in sour milk found lactic acid involved in the name, that is the acid, lactic acid, butyric acid, butter. Again 7, more than 7, that is the 7, that is the neutral. That is water, pure water is neutral. Again, milk of magnesia, it is used as antacid. And whenever we feel acidity, we take more oil food. Oils contain acids. In our stomach, suddenly pain is formed. In that time, we take some basic containing capsules, relieve from the pain. So in that used milk of magnesia, that is the more basic nature. So our acid react with base to form salt and water to become a neutral, the relief from the pain, acid pain. Okay, that is the milk of magnesia. Milk of magnesia is a antacid. And ammonia, lye, these are more pH values, that is the basic nature and a less acidic nature. Okay, this is about pH. Acid rains. How can form acid rains? Already I have discussed. Again, how can acid rains are formed? It is most important. Acid rains are damaged our monuments, historical monuments like Taj Mahal, and so many historical monuments. Means in a long ago, buildings are constructed by the calcium carbonate and calcium oxide, that is the mixture, lime, that is react with acids to form damaged. So acid rain, how can form acid rains? Wastage of industrials, that is the oxides of nitrogen, oxides of sulfur, oxides of carbon, these are mixed with water, that is mixed with rain to form a acids, gives us acid rains. Acid rains are very dangerous. Whenever acid rains are fallen, so many industrial wastages in air, the rain mixed with that wastages to form a acid rains. Acid rains are harmful. Adverse effects of acid rains, that is the fertility in nature, change in the fertility of soil, and change in the damage of aquatic life, and damage historical monuments. So that is about acid rains. Acid rains. Adding certain compounds in the air can cause acid rains. That is, the carbon dioxide can make a carbonic acid. CO2 plus H2O gives H2CO3. That is the carbonic acid. CO2 plus H2O gives H2CO3. That is carbonic acid. Carbonic acid. And again, sulfur dioxide, SO2 plus H2O gives rise to H2SO3, that is the sulfurous acid. Again, SO3 directly combined with water to form sulfuric acid, H2SO4. Nitric oxide can make nitric oxide, NO2. NO2 plus H2O gives HNO3. This is nitric acid. HNO3 named as nitric acid. H2SO4 named as sulfuric acid. H2SO3 named as sulfurous acid. H2CO3 named as carbonic acid. These are all are combined with oxides of non-metals combined with water to form acids. That is the acid rains. Many walled buildings, that is the historical monuments like, and not only nowadays, Taj Mahal, when were constructed, long ago, Red Fort, and our parliament, so many historical monuments are made of limestone. What is the limestone? Calcium carbonate is also called a limestone or marble stone. CaCO3, that is the react with water. CaCO3 gives carbon, CaCO3 plus H2O, or these acids are damaged, that which can become corroded from acid rains. These acids are corroded acids. HNO3, that is the corrosive. H2SO4, corrosive, strong acids. H2SO3, and so on. Again, you can concentrate, students. It is most important concept. Which oxides causes acid rains? CO2, NO2, SO3, SO2, so on. All. That is the all is the right option. Okay, na? Next, acids. I hope you are clear about acids. You take any acid like HCl, like HNO3, like H2SO4, like HCl. That is the properties. Acids are react with reactive metals to form hydrogen and salt. Here taken one equation. Magnesium, that is the metal, reactive metal, react with sulfuric acid to form magnesium sulfate. Can you remember? MgSO4, magnesium sulfate, that is the salt, normal salt. What is the normal salt? It further not give any H plus and OH minus ions, that is called normal salt. H plus ions are given, salt is given H plus ion, that is the acidic nature, OH minus ions, that is the hydroxyl ions, that is the give basic salt. Okay, simply metals react with acids, produce hydrogen gas, produce hydrogen gas, gas escape, evaporated. Again, these are one of the properties of acids. How can prepare acids? Non-metal oxides dissolve in water to form acids. What are non-metals? Elements are classified into three types, you know very well. Metals, non-metals and metalloids. That metal react with oxygen to form metal oxide. Non-metal react with oxygen to form non-metal oxide. Non-metal oxide combined with water to form corresponding acid. Previous concept. What is that? Carbon dioxide, that is a non-metal oxide, react with H2O to form carbonic acid. How can form carbon dioxide? Directly combination with carbon and oxygen to form carbon dioxide. Any other method. Decomposition of sodium bicarbonate, decomposition of calcium carbonate, carbon dioxide can be prepared. Sulfur dioxide, combination with sulfur and oxygen. Any metal combined with, react with oxygen to form corresponding oxide, that is called non-metal oxide. Non-metal oxide. These non-metal oxides react with water, dissolve in water to form corresponding acids. So, these acids react with metals. These acids react with metals. Magnesium, H2SO4, named as sulfuric acid. Sulfuric acid gives the MgSO4, that is the salt and hydrogen. Again, one more property. Acids react with carbonates. Acids react with carbonates to form carbon dioxide, water and salt. And suppose we have taken the HCl plus Na2CO3 gives NaCl plus CO2 plus H2O. For balancing equation, we should write 2 NaCl CO2 plus H2O. This is acid. HCl is acid. Acid react with corresponding carbonate. Not only sodium carbonate, we have taken magnesium carbonate, calcium carbonate, aluminum, so on. Okay. Here produce carbon dioxide and water. Acid, HCl, carbonate, sodium carbonate, Na2CO3, named as sodium carbonate, gives NaCl, that is the salt, CO2, that is the carbon dioxide, water, H2O. Sodium carbonate plus dilute hydrochloric acid gives sodium chloride plus water plus carbon dioxide, same chemical equation. This is for naming of, for chemical equation of the channel. Bubble the gas through lime water to test for carbon dioxide. How can release carbon dioxide? That is the lime water become a milky. That is carbon dioxide. That is the identification of carbon dioxide. Okay, students, one more property. This is a chemical property, last one. After next class, we will discuss the, I think, anybody. Chemical properties, 2 minutes. Acid react with metal oxides and hydroxides to form salt and water. Metal oxide plus acid gives the salt plus water. Metal oxide, that is Na2O or MgO, plus HCl gives MgCl2 plus H2O. MgCl2 plus H2O. For balancing of equation, 2 moles of HCl, MgCl2 plus H2O. Metal oxide, magnesium is a metal, that is the metal oxide combined with hydrochloric acid to gives MgCl2 plus. Yes, Nana? Okay. Do you have any class further? Okay, okay. Just 2 minutes. I will close this. Any doubt? Okay. The uses of acid, sulfuric acid used in detergents and batteries, and not only car batteries, in batteries. Ethanoic acid, that is the acetic acid. Ethanoic acid used in vinegar to preserve the food beverages. Adhesives, that is used as a glue. Hydrochloric acid, cleaning metals in our sanitizer. It is used as a sanitization in our toilets. And leather processing. These are the uses of acids. Again, bases. A base is any metal oxide or hydroxide. One more important point. Elements react with oxygen to form corresponding oxides. Metal oxides are basic, non-metal oxides are acidic nature. That is, the base is a metal oxide, that is the hydroxide, its pH value more than 7. And a base is a substance that react with an acid to give salt and water. Acid plus base gives salt plus water. Similarly, acid plus metal oxide gives salt plus water. That equation I will write in HCl plus metal oxide. We have to write any one, Na2O, that is salt, that is NaCl plus H2O. NaCl plus H2O. For balancing of equation, it is multiplied with 2, it is multiplied with 2. That is the 2 NaCl plus H2O. Acid react with metal oxide to give a salt and water. It is one of the neutralization reaction. Then some common bases: sodium oxide, zinc oxide, copper oxide, magnesium hydroxide, aluminum hydroxide. These are metal oxides. Sodium, zinc, metals. You know very well about metals, I hope. But you don't know, you should concentrate at least minimum 30 elements. What is that nature? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are all metals, or otherwise linely hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. What about the nature? Metallic nature or non-metallic nature? In our periodic table, most of the elements are metals. Only p block elements are metalloids, metals and non-metals. So you should concentrate what their nature. Okay. Generally metal oxides are basic, non-metal oxides are acidic, but sometimes some exceptions are there. Aluminum is metal, but their metal oxide nature is amphoteric. Keep in mind. Zinc oxide also, we will further discuss further classes. Here enough. Metal oxides are basic, non-metal oxides are acidic. Chemical properties of alkalis, that is nothing but bases. Alkalis heated with ammonium salts gives off ammonia gas. Ammonia. Alkalis heated with ammonium salts suppose NaOH plus NH4Cl, that is the ammonium salt, gives NaCl, that is the salt, plus NH3 plus H2O. Okay. Alkalis, that is the base, react with ammonium salts. You are not getting confusion. NaH3, that is nothing but ammonia. 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 NH4 plus, NH4 plus, that is ammonium. 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 Okay. 2 minutes. Ammonia has a strong smell and turn red litmus paper blue. Red litmus turns blue, that is basic in nature. Red litmus turns blue, that is the basic in nature. Only red litmus respond with basic substance, that is become a blue. Again, uses of alkalis, this is the last concept for today. Ammonia solution, it is used in window cleaners. Calcium oxide to make iron, concrete, cement. Calcium oxide, that is the lime, CaO, calcium oxide. It is also called lime. It is used in, lime is used in to make iron, concrete, cement. Magnesium hydroxide, used in toothpaste to neutralize acid teeth. In antacids to relieve indigestion in our stomach full of more acids. We feel pain. The pain reliever. What is the pain reliever? Antacid like milk of magnesia. Antacids to relieve the indigestion. Sodium hydroxide, it making soaps and detergents. So soaps are basic in nature. Soaps. With the litmus test or whenever white shirt on turmeric stain, apply detergent, it become a red. That is the best example for the indication of the basic nature of the substance. Okay. Okay, students, this is our last session, completion of acids, bases, salts. You have any doubts? Tell me, ask me, and you should prepare very well about this exam, coming Sunday exam. It is high time to prepare for exam. You study very well and write very well. Okay, students. Bye all of you.